For loops and iterators. Nim has first-class iterators and syntax to use them. For loops. The continue and break keywords also work inside of for loops. There are two kinds of iterator and two special methods that for loops work with. Could use some better formatting to specify. Okay, items and pairs. Sure. When iterating over an object with one item, Nim will call an iterator called items, with the first parameter the type you want to iterate over. The same thing happens when iterating with two items, but in that case the pairs iterator is called. Okay, so it looks like we're defining some kind of type, custom range, that is an object that has low and high value. Oh, so there's a keyword iterator, so we can oh, I like that it's just straight up, this is an iterator, no weird stuff. It's an iterator and it just has a name items that takes the range, custom range, and returns an integer. So we can do set that we start at low, and we just do the while loop, and we yield I. We increment it, and just keep going, keep going, keep going. Okay, that is so simple to make iterators. Wow. Okay. And pairs is basically you need to return a tuple, A and B. Okay. In that case, you're just going over characters. That's simple, and it just returned the I. Okay, I in range. Oh, that is very. Oh, because range. Yeah. So for that. Oh, so we're reusing this just to go over the elements 1, 2, 3, 4. We do that, but uses custom range items, so we can do for I and C. Okay, we actually are iterating over numbers, right? Therefore, we'll get like numbers from low to high. So. Yeah, here we basically we can specify again a range from like here, a range from 1 to 3, and then it will return characters, just like that's what we want. So okay, I see. Okay, it makes sense, right? So we do for I in range, so this will be basically iteration from low to high. So in this case it'll be from 1 to 3, and because we have an I here, we return it to have the index. And then we just make up a character of whatever it was and add the A. So okay, that's different. So we take the character A and we convert it to a number using ORD as ordinal, I presume, and not just integer. And I is defined as integer. I guess when adding it doesn't matter. Again, let's ask AI. Let's see what happens. So consider this code. Okay, we've got the code and the iterator pairs. We call ord A. Why not call, and this will be int A, right? Because we're using integers here. So that's my question. Why ordinal over integer? So both ordinal and integer can be used to convert the character A to its corresponding integer value. However, there's a slight difference between the two. Ord A is a built-in procedure that returns the ordinal value of a character. For characters, the ordinal value is the ASCII code of a character. In this case, this returns 97. Integer is a type conversion that converts the character A to an integer. In Nim, when a character is converted, it also returns. So what's the difference? There's really the same result. There are a few reasons. So ord, readability, stands for ordinal and is well known and widely used proc for obtaining the ordinal value of a character. It clearly conveys the intention of getting the ASCII code of a character. Okay, as in we're not parsing into int, right? We just want ordinal type. It's commonly used when working with ASCII codes. Okay, standard idiom and Nim and other programming languages to use ord for character to integer. And specificity. Ord is specifically designed for obtaining the ordinal value of an enumerated type, including characters. It provides a clear and specific way to convert a character. Okay, so on the other hand, int A is a more general type conversion that can be used to convert various types of integers. While it works for characters, it may not be as immediately clear that it is being used to obtain the ASCII code. Okay, so I guess it's just in Nim when you converting character to some numerical value, just use ord. Okay, it's a convention. I don't mind. I understood it. That's what matters. Okay, that's simple. Operators. Iterators can also be operators in the standard way, with the name enclosed in backticks. For example, the standard library defines the slice iterator, which allows iterating through ordinal types. So give it a different name to avoid conflict. Iterator ... and a star of type T. It takes A and B of the type T and returns that type T. So this is the generic iterator, which is basically a ... So variable res as result. So we assign A, right? While result is less than B, yield it. And then keep increasing until it basically goes to B. Okay. Oh, I see. An increase. So here we define 0.5, which is the equivalent of already built in ... I see. Okay. That's funny how they can define that. I really like that. Although it would probably confuse the hell out of some people, like, wait, what? Why are we having 3 dots suddenly? Huh, that's cool. And I guess because we can call things in a wacky way, we take the 0, which is in this case type integer. Therefore, when we do ... the 0 takes place here and expects another integer here. We give it and returns another integer. I mean, the whole iterator. I really like it. Oh wow, there are so many ways you could use it. Huh, that's fun. I like it. Much fun. Inline iterators. Okay, we're getting into fun land of iterators. Inline iterators basically take the body of the for loop and inline it into the iterator. This means that they do not have any overhead from function calling, but if carelessly created, may increase code size dramatically. Ah, okay. So basically take the body of the for loop and inline it into the iterator. Which is iterator, count 2, and it just takes an int and gives an int. Okay. So yeah, we just define it with one value. But how is it inline versus... Oh, so this is what we were defining already. This whole code will be inline into here. Okay. So that's our standard way doing the inline. But because of that, everywhere where we're using it, we're basically copying the code. So if you would use it a lot, it could cause a lot more code to be generated. So if you don't want to deal with large executable and you don't care about performance as much, you could use closure iterators. Closure iterators hold on to their state and can be resumed at any time. The finish function can be used to check if there are any more elements available in the iterator. However, raw iterator usage is unintuitive and difficult to get right. So let's look at that. Procedure. Count 2. We'll give it that integer. How many times? What to count 2? And it returns an iterator. Okay, that returns an int. So return... Oh, wow. Okay, so we're literally return the whole iterator. That's funny. Huh. And it just iterates from 0 to... that number. So if we do let count to 20, that will be our iterator that we get here. Nothing is iterated over yet, right? So when we do echo, it shows 0. Oh, so basically when you echo the thing and execute it, we just executed a single thing. Okay. So then the output will be raw iterator usage. While true, so we just go forever. The next is count this. So grab an element, it's just executed, and that will just return one element. So you could just copy that bunch of time and it will execute that many times. Is the element bogus? So it's the end of the loop, discarded. Okay, so if finished, count 20, then break. And if it's not, output the next. And I guess convert it to string. Okay, so why are we getting it first? That's curious. So if we have it count to 20, that should count to 20 including 20. So it did 0 for the first time when we echoed it here. So we already took the first element out. And then in the loop, we're going until we get to 20. So in this case, we went here, we grabbed 20, and it didn't say finished yet. So does it mean that we get the result if it's finished or not only after we call it once more and get like nothing? And what is the state of next at that point? Let's try it. Let's ignore that part. Let's just grab this part. So I'm gonna paste it here. So let's do something in addition. So if finished, break. But let's just do echo the value of finished element, and we can do the next, right? Just like that. Let's try to run it because I'm curious what's gonna happen. The value of finished element is 0. Oh, so it just zeros it. It doesn't crash, it just zeros it. Okay. So we basically went... Wait, we didn't print anything? It finished. Just instantly finished. What? Why isn't that called? I don't understand. If I'll just put that here... Output.add. Oh, right. We just need to print it. Where is it? I'll just echo output. Okay. And if we do that... So basically, we took 20, the last element. We took it, and it at that point it doesn't say finished. So it doesn't say if there is one more element. It only says if it finished as in already took the last element. I mean, already took the after next element. Interesting solution. And only then we break. So basically, we took 20. This didn't say it's finished. It added 20, starts another loop, asked for another one, and got just a default value, which in this case was 0. But finish at that point said, yeah, we're finished. Very interesting. Not sure if I like it, because I personally would prefer to ask if there is one more iteration or something. But I guess it doesn't know. Oh, I see. It doesn't know because at the moment where this returned 20, we are just here. And when finished, we're basically asking it, did you do yield break or did you just get out of the loop? Therefore, it doesn't know ahead of time. Okay, it makes sense. I'm just being silly. Okay, makes sense. Therefore, I like it. Continuing. Output, we reset the output and basically say count to 9. And we can just say for n and count to 9, we output it. Okay, so the thing is that with those closure iterators, we can basically take the iterator and use it in multiple places. Like we got something here, and then maybe we did something here with it. We just need to manually check if it's, finished here or not. So this is a little bit more of how you would deal with iterators in C#. They are called enumerables and enumerators, where you can basically say, list, get me an enumerator, and then you can enumerate with next, and check if it's finished. Okay, I see. So yeah, it's pretty clean.